Imagine the ground beneath your feet suddenly erupting in a violent shake that could level cities elsewhere, but in the wild heart of Alaska, it's uncovering secrets buried under centuries of ice. Is this earthquake the key to a long-suspected geological mystery? In the frozen expanse of Alaska, recent seismic activity might have exposed a connector fault that experts have hypothesized for years, hidden beneath the Hubbard Glacier. Just a few days ago, an intense magnitude 7 earthquake jolted areas up to 500 miles away, originating right under the Hubbard Glacier. This powerful event, along with its swarm of over 2,000 aftershocks, has done more than just rattle nerves. It's potentially etching a new understanding into the Earth's crust, revealing a fault line that scientists have long pondered beneath the icy veil. To grasp the gravity of this, let's hear from state seismologist Michael West at the University of Alaska Fairbanks, part of the Geophysical Institute. He reminds us how desensitized we can become to earthquake scales in a seismically active place like Alaska. A magnitude 7 is an absolute monster of an event, he explained. To put it in perspective, if something this size struck Afghanistan, it could result in devastating losses, with estimates of up to 10,000 lives affected. Fortunately, in this remote Alaskan region near the fishing village of Yakutat, and extending into the rugged Yukon and British Columbia borders, no injuries have been reported. However, the landscape tells a different story. Glaciers in the area are now blanketed with fresh rock debris from triggered landslides. As West described it, this was intensely forceful. It dislodged rockslides everywhere in the vicinity. But here's where it gets controversial. This earthquake and its numerous aftershocks have drawn sharp attention from researchers who've spent years piecing together clues about enormous fault networks separated by some of Earth's most expansive ice fields. Think of these seismic events as a form of natural pointillism, the art technique invented by French painters in the late 1800s where individual dots on a canvas eventually form a complete image. The Hubbard Glacier quake on December 6 has sketched a rough outline under the ice, leading some experts to believe it marks a connector fault linking established fractures in the planet's thick outer layer. These underground fractures are sometimes visible on the surface. Take the Denali Fault, for instance, which cuts a straight, often ice-choked gash across central Alaska, nestled between towering peaks. Or the Fairweather Fault, an extension of the famous San Andreas Fault, slicing through the rugged terrain behind Lituya Bay. This particular fault was behind a dramatic 1958 earthquake that sent a mountaintop crashing into the bay, generating a colossal 1,700-foot tsunami wave, the tallest ever documented. By analyzing the patterns from the December 6 quake's main shock and smaller tremors, scientists are spotting a compelling alignment. And this is the part most people miss. Retired U.S. Geological Survey scientist emeritus Peter Haeussler, excitedly chiming in while cruising on his 45-foot sailboat in Mexico's Sea of Cortez, calls this jagged feature the connector fault. He references pioneering geologists like Don Richter and George Plafker, who decades ago theorized that two of Alaska's primary fault systems must connect invisibly under the vast ice sheets where southeastern Alaska meets the mainland. They had strong suspicions but lacked the means to investigate such perilous, high-elevation, ice-covered terrain. There's this huge swath of land between the Totschunda Fault, a branch of the Denali that broke in 2002, and the Fairweather Fault, all shrouded in glaciers, at dizzying heights, and incredibly hazardous, Haeussler noted. Julie Elliott, a research professor at Michigan State University, was pursuing her PhD at the University of Alaska Fairbanks in 2011 when she mapped the area's subtle creeping motions using precise GPS data. In her doctoral thesis, she modeled a connector fault running beneath the ice, tracing the paths of glaciers that scientists suspected could outline a concealed fault. Preliminary analyses of the aftershocks show they align strikingly well with my modeled fault line, she shared. It turns out those early geologists were onto something solid with their idea of a fault lurking under the ice fields. As additional aftershocks continue to add dots to the map, West remains cautious about labeling this quake as definitive proof of the connector fault's existence. He and fellow experts describe the region as a geological chaos zone, where the Yakutat microplate, a substantial slab of Earth's crust, slides and crashes into Alaska, triggering earthquakes along strike-slip faults. These are faults where motion occurs horizontally in both directions, much like two trucks speeding past each other on a narrow road, exemplified by the Fairweather Fault. This ongoing tectonic clash has sculpted some of the world's most impressive coastal mountains, including the 18,008-foot Mount St. Elias and 15,300-foot Mount Fairweather. This region is inherently messy and complex, West observed. He believes the Hubbard Glacier earthquake likely exposes the southern tip of a connector fault, but the spread of seismic signals northwestward suggests another, shorter fault might be at play. It feels more tangled than a clean 50-kilometer rupture, he added. Scientists are itching to visit the site immediately to inspect for surface ruptures, similar to the 200-mile-long scars revealed after the 2002 Denali Fault quake. Yet, challenges abound. The event struck in December's dim light under a fractured ice field 67 miles from the closest town, Yakutat. "I'm a little bummed it occurred in winter," Elliott admitted, as it complicates access in such a harsh, remote environment. Here's the controversial twist: could this connector fault be a game-changer in predicting future quakes, or is it just a fleeting glimpse into Alaska's volatile underworld? What do you think? Should we prioritize more exploration of these icy frontiers, even at great risk and expense? Or does the lack of immediate danger mean we can afford to wait? Share your opinions in the comments. I'd love to hear if you agree, disagree, or have your own take on how we should handle such geological enigmas.